Hi, coming to exam 1 video. I have taken the question and solve of root equations in recurrent relation t of n equals to t of under root of n plus log n into log n. We can consider it in the form we have to apply Master's theorem on it. We need something into the form of t of n equals to a into t of n by b plus f of n. This f of n can be something which can be in the now this f of n can be of anything like constant 1 or some value. Like to convert this t of underscore of root n into t of something by phi form. Let's to apply Master's theorem. Let to convert into this form. Let's do some background work which is required. Let me explain something about the Master's theorem. Initially, the Master's theorem for dividing function. Let me erase it. So, yeah. Initially, the Master's theorem can be divided for dividing functions which is of t in the form of t of n equals to a into t of n by b plus f of n. The requirement is that this a should be greater than or equals to 1. Why this should be greater than or equals to 1? This master theorem has come from this root form. Here, the value of a, the number of branches, this is the value of a. Here we can take this as a equals to 3. This a means that the number of branches, this number of branches should be at least 1. Minimum number of branches is at least 1. So we have taken it as a is greater than or equals to 1 here. And b, what does this b mean? The b is this dividing value. This dividing value should be at least 1 because n by minus 1 doesn't make any sense. The negative value doesn't make any sense. When it is at least by 1, it means it is n. When it is by 2, n by 2. When it is a dividing function, the value should be at least 1 to get it divided. So the value of b should be at least 1 in this function. So is the reason we have taken as a is greater than or equals to 1 and b is greater than 1. And this f of n can be of any form. Here it is any form in the sense it can be constant or 1 n square. So to make it into a function form, we have considered it as order of n power k log n to the power p. Here anything is in the, we will be considering it as the base n, all logarithmic functions of base n. Now let's calculate. Now let's see how to evaluate the Master's theorem. To evaluate the Master's theorem, we'll be considering two parts here. Log a to the base p, the value of log a to the base p, and value of k. Value of k we have got from n power k from this function, like in the form of log n. Here it is p. This k, and like we can have a relation like less than, greater than, or equals to between anything. Now the comparison is between this and this, less than, equals to, or greater than. When this value is greater, when log a this is greater, this should be the dominating part. When this is the dominating part, there is no need, k doesn't make any sense. We have to only consider this value and it becomes order of n power log a to the base p. Here we can see that n power log a to the base p. Now coming to the second one, like when it is equals to function. When it is equals to function, this part and this part is equals to. Then the value of p comes into the picture, and it divides into when, and it can be of three cases. When p less than equals to minus 1. When p is greater than minus 1, this goes into the order of n per k log p plus 1 into the n. It is a general form of n. We have considered of it is like n per k log p per n. As p is like it's greater than minus 1, like it could be like minus 1, 0. And then we are adding 1 to the power of p. When p equals to minus 1, we have taken as order of n per k log of log n. When p is less than minus 1, we have taken as n per k. Because when p is it's less than minus 1, like minus 1, minus 2, minus 3, it doesn't make any sense. It is like when log power minus 3 to the base n, like it will be like 1 by log 3 to the base to the n. It doesn't make any sense. Its logarithmic value is too small to get considered. So we have removed this log n, this log p power n, and we have considered n only the order of n per k. Now let's take the case 3. When k is greater, the value, log a to the base p doesn't make any sense to us. It means log a to the base p doesn't make any sense, and k value matters. So we have considered the n per k, and we have here you can see we consider log a to the base p as it is making more sense. We have removed that log a to the base p, and we have put n in that as k is more priority and it is making sense. We have put n per k. And here, when the p value comes into the picture, like p is greater than or equal to 0, p is less than 0. When p is less than 0, as said previously, it would be like 1 by log of log something. As it is too small, we did not consider it, and we have taken only big O of n per k. And when it is greater than or equal to 0, we consider the complete f of n function as n per k into log p to log n to the power p. So let's see some examples in case 1, case 2, and case 3. Coming to case 1, for example, let's see this one. T of n equals to 8 into T of n by 2. Here A is 8 and B is 2. And here K is 1 and P equals to 0. When we calculate that, log 8 to the base 2, it becomes 3. Correct? And K is 1. Means this side is greater. As this is greater, we can measure big O of n power log 8 to the base 2. It is 3. So we have taken as n cube. Coming to the case 3. Let's answer this one. A equals to 2, B equals to 2, C equals to 2, A equals to 0. Now, log 2 to the base 2 is 1, and K equals to 2. K value is greater, it becomes case 3, right? And the P value is 0. When P is 0, this is a 1 we have to consider, right? Order of n per k log to the base n. As n is 2, it becomes order of n square. Order of n square. Now let's come into our problem. As we got something how to solve these things, now let's come and see the problem. It is in the form of t of n equals to t of root n plus n of n. Now we have to make it into the form of t of n equals to a into t of n by b plus f of n. Correct? So let's consider this root n. We have to convert this root n into the form of n by b. So let's consider n equals to 2 power n. When n equals to 2 power n, then as it is a logarithmic function, as we need something in the form of logarithmic function, it becomes log n to the base 2 equals to m. When this is nothing but log n to the base 2, which is equals to the value of m. Now this is m, as n is 2 power m, which I have written here to make it easier. Yeah, this is what I've done. I've taken n equals to 2 power m and log n to the base 2, which is nothing but this one, is equals to m. When we take that, it becomes m square here, this is m square here, and n is 2 power m here, and t of root n, which is something like t of n power 1 by 2, and this n is m by 2, right? Sorry, 2 power m by 2, right? So this becomes 2 power m by 2, which is this one. Now we need something in the form of t power t of n by b. This thing should be in the form of t power n by b to complete to write it in the form of Master's theorem. So let's convert it to the function of s of m equals to, when this completely is m, this becomes m by 2 because 2 power m by 2 square, right? So this has become m by 2. Mm. Now we can easily apply Master's theorem on this. When I apply Master's theorem, you can see that the value of A is 1 and the value of B is 2. This is A, this is B, and this is K. When there is nothing here. It means like log 0 to the n. Like this 0 is the value of B. So we have got A equals to 1 here, B equals to 2 here, K equals to 2 here, and P equals to 0. When I calculate log A to the base B, here log 1 to the base 2, correct? And the value of K equals to 2. It means we can write this K as in the form of like log 4 to the base 2. That becomes log 2 square to the base 2, which is nothing but 2 log 2 to the base 2. This value is 1. Now 2 into 1 equals to 2. This is the value of K. To compare it easily, I have written it in the form of this because both are in the log 2 form, base 2. This 4 is greater than 1. It means that k is greater than log a to the base b. When log a to the base, when k is greater, the case 3. As I explained previously, it is case 3 form. Here you can see that it is greater than k, it is case 3, and we have a value of k which is greater than equal to 0. Now it becomes log of n power k log n to the power p. Now let's substitute the value. We have got k equals to 2 here. As we have everything in the form of m, our function is f of m, sorry, s of m, right? So our values are taken from this equation, m form. So now take the values from this. Our k is 2. Substituting 2 here, it will be m square log sp equals to 0 log 0 to m. As this equals to 1, anything to the power of 0 is 1. It is order of m square. From the above, we calculated initially n equals to 2. We have taken n equals to power m and taken this. Now we have n. We have to convert it into n because our equation is in the form of n. Our final thing should be in the form of n. So replacing m with n, it becomes log n to the base 2 whole square. Thank you.